Okay, we ever take a tricky integral? This one's from Caltech Math Meet 2025, Finals 45. We have the integral from 0 to 1, arctan x squared minus x plus 1 dx. Okay, so I say it was tricky because I tried like 10 things before I could get something that worked. I definitely think I'd have trouble if there was a time limit because you don't really get enough time to try 10 different things in an integration bee. But the first thing that I found that was kind of promising was we have this identity here that we can say if we've got arctan of x, then adding it to arctan of the reciprocal, this is just going to be pi over 2 with the condition that x needs to be greater than 0. I'm not sure about greater than or equal to 0, but either way, our bounds tell us our x values are going to be greater than 0. So using this and rewriting it for our problem, we want to just isolate that. So it's going to be arctan of x equals pi over 2 minus arctan 1 over x. So what I'll do is rewrite the integral using this, where the input on the x is just going to be this whole thing right here. So now with it written this way, we've got a constant. This part's easy to deal with, but this part, it doesn't seem any better at all. It seems like I probably just made it worse. Initially, when I was trying things, one thing I tried was factoring this. Doesn't factor by integers. You can complete the square, but what does that do for us? Well, again, we can complete the square, but how does that help? We don't have a real good way to deal with this with, a factored denominator. But working with this, we can try to make something happen. So what about if we have something like this, x times 1 minus x, you multiply that out, you get x minus x squared. So kind of like that, just reversing the sign. Now, if we do something else, what if I do really similar, write it like this? So basically, we're just adding 1, reversing the sign. We get 1 minus, distribute into this, minus x plus x squared. That's the same thing as this in a different order. So we can write it like this, x squared minus x plus 1. For that denominator, we can write it like this. So trying to put it back together as a fraction, the denominator, I want it to look like this, 1 minus x, 1 minus x. Now, using these two parts here, we have 1 in the numerator. If I add these together, add x plus 1 minus x, this is still going to be a 1. And now we've achieved these same parts that we have down here. And this whole thing, this is going to be inside of our arctan. But now expressing this thing like this, we actually have a formula for this that we can use to try to transform this. Okay, up to the right, we've got our addition formula for arctan. I think I derived this in a previous video, and I did something with it actually very recently in another integral. But anyway, this piece over here on the right, this is exactly the form that we want here. Just kind of labeling things. Let's call this part A, this part B, and then we've got A and B down here. And all we want to do is go in reverse and look at how simple it becomes. It just becomes arctan of A, arctan of B. So rewriting this piece and putting it back into the integral, we've got integral from 0 to 1, pi over 2. I'll split it into 3 separate integrals now because we're going to create this as 2 separate integrals. So we're going to have minus integral from 0 to 1. We'll take this first part where the A is going to be x. So this integral is just going to be arctan of x. And then for the last integral, I didn't really give myself the right amount of space, but let me kind of wedge it in here just so we can see it. So it's just going to be arctan of this b value, which is going to be 1 minus x dx. But now we're all set up. This is very simple. This is pretty familiar. We can do this. Let me just deal with this one first, and then I think we can finish it off. Okay, now for this integral on the right, I just want to transform it really quick with King's principle. King's principle allows us to just add the bounds, keep everything the same, variable the same, add the bounds, subtract x. So it's like we want f of b plus a minus x, where this is going to be a and this is going to be b. So in our problem right here, adding the bounds is just 1. So we're looking at f of 1 minus x. Notice that's the input we have right there. So when you do it, the integral you get back is just 0 to 1 arctan of x. Just noticing if you plug 1 minus x in here, you get back x. I mean, another way you could do it is just do it out with a u substitution, but in a situation like this where it's perfectly lined up, you can just kind of do it in your head with King's principle. But if you transform it, now look what happened. We got the same integral here and here. So we can actually condense this and just consider it 2 copies of this integral right here. So I can make this a minus 2. And that's just going to simplify our calculation a little bit. So let me erase this one. And now this arctan integral is a really common integral. We can just do it with integration by parts, doing it with the DI method over here. So we only have one thing, so we'll differentiate that, create a 1 in front to integrate. So we're going to integrate 1. Doing it, this is just going to be 1 over x squared plus 1. Integral here, this is going to be an x. So we get part of the solution there on the diagonals. It's going to become, just kind of doing it off to the side, we're going to have x, arctan of x from 0 to 1. And then here, we're going to have this integral minus x over x squared plus 1. Now for this one, when you evaluate at 0, that's going to be nothing. Both parts are 0. You evaluate at 1, you get 1. Arctan at 1 is going to be pi over 4. So we'll just capture pi over 4 there. Here, we can set up a u substitution. We'll kind of do this one in our head. Multiply into 2. So I don't change it. We'll multiply by a half here. That way, what's happening is if we call this thing u, then everything up here is du. So doing that out really quick, we get minus 1/2 natural log. It's always positive. Plugging right back in, it's going to be x squared plus 1 evaluated from 0 to 1. Again, the 0 part's nothing because you get a natural log of 1. So we're just worried about plugging in 1. What we're left with for this is going to be pi over 4 minus 1/2, and then this becomes natural log of 2. So let's see if I can plug it all in and finish it off. So over here, this is just going to be, let me write it out. So it's going to be pi over 2x evaluated from 0 to 1 minus 2 times this stuff. So we end up with pi over 4 minus 1/2 natural log of 2. But over here, evaluating this, plugging in 1, we're just going to get a pi over 2. Then distributing minus 2, we get minus pi over 2. Distributing minus 2 to the last term, we're just going to be left with plus ln 2. But this right here is going to cancel, put it together, and for my final solution on it, we just get natural log of 2, and that's it. So there you go. After the first step, it's really easy. It was just a little bit hard to see. I mean, I'm used to doing this first part, pulling out a pi over 2, but I think it's hard to know what to do with this exactly. We don't see this very often, and arctan can be hard to work with, so this part, definitely not easy. Anyway, that's it for today. Thanks everyone for watching. Have a good day.